bucket. Queries on extendable hashing. Here each bucket j stores value ij that I have shown you in the previous. This is ij, I1, I2, I3. Okay, this is ij, we can say I1, I2, I3. Bucket number j, that is given there. Okay, how to locate the bucket containing search key value kj? Suppose we want to locate a record. We are not going to considering insertion and deletion. We consider if we want to locate a record with the search key value kj. What we need to do here? We need to compute. We need to compute h of kj, the hash function, whatever given. Whatever the given hash function, according to we need to create the value. Use the first I higher order bits of x as displacement into the bucket address table and follow the pointer to appropriate bucket. Now see here, for example, again suppose we want to search a record or we locate a record. So in that case, suppose I want to locate a record with some hash value h of music. Then it gives some value 0, 1, 0, 0, 0, 0, something. 32 bits are there hash value. Now, how to locate a record? Search the record with the first I bits. What is I is equal to 2. So, first 2 bits start with the hash address table where it is 0, 1. Then, first 2 bits are 0, 1. Follow the pointer, it points to the bucket number 1. Here we will get the record with music department. Here we will get the record with music department. Everyone clear? How to locate a record? Compute a hash function on the search key h of music, for example. Suppose it gives this hash function I is equal to 2. Then in that case, first 2 bits are considered. Follow the pointer. This gives the address of the particular bucket where the actual record is stored. Is it clear? Now the second one, if we want to insert. Okay. If we want to insert a record, to insert a record with the search key value kj, to insert a record with the search key value kj, follow the same procedure. Compute h of kj, it gives some hash value. If I is equal to 2, first 2 bits are considered. Follow the pointer and check the bucket. If follow the pointer to locate a bucket. So, if there is room in the bucket J, insert the record into the bucket. If there is a room, insert the record into the bucket. But if there is no room in the bucket to store the record, then split and insert to reattempt. Then split and insert reattempt. For example, in this case, suppose I want to insert a record, then suppose I want to insert a record with finance as a search key and then compute a hash function. It gives suppose some value 0, 0, 1, 1, 0, 0 something. I is equal to 2. So follow the first 2 pointer. See, is it visible whatever I have written on the PPT? Otherwise all will be wasteful. Yes or no? Is it visible? Okay. So suppose we want to store a record, insert a new record with the finance department as a search key. So compute h of finance, it gives some hash value. In that I is equal to 2. So consider first 2 bits, follow the pointer. Now suppose there is a space. Here it is music is stored and there is a space. So I store it here, finance. But here already there is some record, bucket is full. There is no space. There is no space. So what we need to do here? We need to split the bucket. Now, when in this case, when we need to split the bucket, check what is the value of I1 or Ij. What is the value of ij? If ij means I1 is less than I, what it indicates? It indicates that multiple pointers point to the same bucket. What it indicates that? Multiple pointers points to the same bucket. Same, I am again repeating. I am trying to insert a record with the search key value finance. But there is no space in this bucket. It locate me 00, locate me here. But there is no space in this bucket. What I need to do? Bucket is full. So I need to add it another bucket. Now check whether we can split the bucket. So if I1 this is less than I means what? It I1 is less than I means it indicates that multiple pointers point to the same bucket. So in that case only insert a new bucket. Only insert a new bucket here and half of the pointers point to the first bucket and half of the pointers points to the second bucket. Then in that case, what we need to do? Add this finance here. There is a space. Finish? Okay. Now, another case. Suppose here there is a record with history and another with biology. And I am trying to insert a record with electrical engineering. And it gives me 101010 something. So I is equal to 2. So first two bits are considered. Follow the pointer 10 first two bits here. There is a space in the bucket? No, there is no space. What I need to do? I need to insert this record with electrical engineering another bucket. So can I use and insert here another bucket? Check. Here I2 is equal to I. And if I2 is equal to I cannot add here another bucket. Why? Because single pointer points to the bucket. So I cannot add another bucket. So in that case, it is not possible to insert a bucket here. So in that case, what I need to use? I need to increase the size of I. It becomes 3 and accordingly increase the size of bucket address. 0001, 100, 101, 110, 111. And then I can insert a new bucket here. Is it clear to everyone? So in that case, half of the pointers points here and half of the pointers point here. That we will see with example also. That is about the insertion. Then again the same thing is there. First we need to locate a record. First we need to locate a record. For example, suppose I want to delete a record whose hash value is 0, 1 0 0 0 0 something. So I is equal to 2. So we observe the first two bits to locate a record. So 0 1 follow the pointer. Here the record is there. Delete the record. So delete the record. If in this case we delete all the records from the bucket, we need to delete the entire bucket. We need to delete the entire bucket. And in that case, if the bucket is deleted entirely, we need to adjust the pointer accordingly. And in some cases, it is possible to minimize the value of I. It is required to minimize the value of I in the case of deletion. Is it clear to everyone? Deletion. Now see one example we are going to see here one by one how the values are inserted into the buckets. Okay, insertion we have seen, deletion. Now this example we are going to see here. We are going to see this example where these values are there. We are going to consider here the department name as a search key value. We are going to consider department name as a search key value. So here different departments names are there. Accordingly, what we actually perform is hash file organization. We compute h of ki on all the search key value which gives some hash value, and accordingly we store the buckets in that particular, or store the record in the particular bucket. Now see here, in this you can observe it. So department name is considered as a search key value, and suppose these values are calculated here. Biology department 0101 32-bit value as B is equal to 32. Computer science, these values electrical, finance, history, music and physics. So these values, considering these hash values, these are according to the hash function whatever used. These values are calculated. Now using these values and these records, okay, these records we are going to insert into the dynamic or using the extendable hashing. So initially we start with, I'm going to use here easy board. Okay, so initially we start with I is equal to 1. So I is equal to 0, no buckets are there. Next we start with I is equal to 1. So I is equal to 1 means 2 raised to 1 is equal to 2. So in bucket address table there are 2 entries. In the bucket address table there are 2 entries. Is it clear? Okay, so 2 entries. One indicate the pointer which point to the records which start with 0, and another which point to the records which start with 1. Initially we consider there is only one bucket, and in one bucket we can store 2 records. Okay, so single bucket is there, so both the pointers points to the same bucket. It is bucket number 1, I1. Now I is equal to 1 and I1. All the pointers, 2 pointers points to the same bucket. So what is I1 here? It's a 0. Why? Because 2 pointers points to the same bucket. If there is a single pointer points to the bucket, then it is equal to I. Otherwise, it is less than I. So I is equal to 0 means not necessary to do anything. There is a single bucket. Whatever the first record, it goes into that bucket. Now see, what is the first? This is, sorry, this is Srinivasan, computer science, whatever the salary and the ID 101. So first search key is computer science. Now check the computer science hash value. What is the hash value of computer science? 10. First bit we are going to consider only. So it is 1011. There is a single bucket, so it goes into the first bucket only. So computer science and the whatever according to hash value, these record is stored in the computer science. So 10101 Srinivasan. Okay, computer science and salary whatever 65,000. Now we move toward the next record. What is the next record? It is U finance 90,000 12121. Now finance, what is its hash value? 10101. Now there is a single bucket, so directly we put that value in that bucket. So 12121 U finance, and I forgot, maybe 90,000. Okay, so in this way first 2 record we stored in the bucket number 1. Now we move towards the next record. What is the next record? It is Mozart with music department. It is Mozart with music department and its key is 0011. Now Mozart with which department? Music department. Now it start with 0, go here. Is there space in this bucket? There is no space in this bucket. Now what we need to do? We need to first check whether we can split the bucket. Yes, we can add a bucket or split a bucket, create a new bucket. Okay, we can create a new bucket. Why it is possible? Because I1 is less than I1 is less than I is equal to 1, I1 is equal to 0. Means what? Multiple pointers points to the same bucket. Multiple pointers points to the same bucket, and that's why we can add a new bucket. We call it as a bucket number 2. We can add a new bucket number 2. Now what we need to do the next? We need to do the next step. Half of the pointers points to the first bucket and half of the pointers points to the second bucket. Half of the pointers points to the first bucket, half of the pointers points to the second bucket, and again we need to reorganize the records accordingly. 3 records we are inserted. Now we need to reorganize the records accordingly. So what is our first record here? Srinivasan Computer Science. Now here in this case, what is the value of I1 now? 1 by because a single pointer points to that bucket, and I2 is also 1 because the single pointer points to that bucket. Means while we are inserting these first 3 records, we need to consider the first bit. We need to consider the first bit and accordingly insert the value. Now the first one is computer science, Srinivasan. Now see computer science here. First bit is 1. First bit is hash value is 1. So accordingly follow the pointer, it is 1. Follow the pointer 10101 Srinivasan computer science 65,000. Now we move towards the next one. What is it? Ooh, with finance. Where is the finance? The first bit is 1, and that's why finance. Follow the pointer of 1. It comes here 12121. Ooh, finance 90,000. Now the third one. What is third one? It is Mozart. Correct? With music. So music, which is the first bit is 0. Only first bit we are considering. Why? Because I is equal to 1 and I1, I2 is also 1. So first bit is 0. So here it is 0. Follow the pointer. Is there space in this bucket? Yes, there is a space in this bucket. What is value? 15151 Mozart music. 15151 Mozart music 40,000. Now we move towards the next one, that is Einstein with physics. Now see physics. What is the first bit? We consider only first bit. Why? Because I1 is equal to 1, I2 is equal to 1 and I is equal to also 1. So we consider only the first bit. What is the first bit of physics? It is 1. So where it goes? 1, follow the pointer. So is there space in this bucket? Is there space in this bucket? No, there is no space. There is no space. Can we split the bucket? We can split the bucket if I is greater than I2. But what happens here? I is equal to I2. I is equal to I2, and that's why we cannot split the bucket. We cannot split the bucket. What we need to do here? So here we increase the value of I by 1. 2 raised to 2, it becomes 4. So here I need to add 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now, in this case, we need to update the pointer. Here I add first one bucket. First I add here one bucket where we are going to insert the next record. Now, 3 buckets are there. We need to adjust the pointer accordingly. First half of this pointer, it points to this one, this here and this one here. Is it clear what we have done? We increase the value of I by 1. So here it becomes the 4 entries in the bucket address table. Accordingly, here there are 3 buckets. So first 2 pointers point to the first bucket. We add a new bucket here. So half of the pointer goes here, half of the pointer goes to correct. 2 pointers points to the same bucket. It is 2 minus 1, that is 2 minus 1 is equal to 1. So I1 is equal to 1 means we consider only the first bit. If it is start with 0, it goes into the first bucket. What is the value of I2? What is the value of I2? You are giving the answers. May see you understood the concept. So 2. What is the value of I3? 2. A single pointer points to the bucket. That's why it is equal to I. Now we are trying to insert the record with Einstein and physics. Correct? For that, what we need to do? Again, we check the previous records are at correct position or not. Srinivasan, computer science. So computer science, first 2 bits, I is equal to 2. Correct? So first 2 bits are 1, 1. So 1, 1. Where we need to add the computer science now? Again, reorganization of records is required. So computer science, it start with 1, 1 something. First 2 bits of computer science are 1, 1, 1, 1. So first 2 bits 1, 1, follow the pointer 1, 0, 1, 0, 1, Srinivasan, computer science and the salary. Next one is U finance. What is the finance? First 2 bit 1, 0. Okay. So 1, 0, follow the pointer. Here we add U finance. Next one is music with Mozart. Music is start first 2 bits are 0, 0. So sorry, first 2 bits are 0, 0. It is here. So follow the pointer. Here we add Mozart music 1, 5, 1, 5, 1. Now we are trying to insert the Einstein. What is its first 2 bits? Physics. What are the first 2 bits? 1, 0. Correct. So 1, 0, follow the pointer. 1, 0, is there space? Yes, there is a space. So Einstein physics. So I think it is clear to you up to this. Now we move towards the next record. What is the next record? Il Said with history. The fifth record is Il Said with history. What are the first 2 bits of history? 1, 1. Now check whether there is a space. 1, 1, follow the pointer. Yes, there is a space. So insert it here. History, Il Said 3, 2, 3, 4, 3 something. And some salary. Now the next one. What is the next? Again the physics. Correct? Physics, it is start with 1, 0. It is start with 1, 0. Follow the pointer. Is there space? Yes or no? There is no space. Can we split the bucket? See, 1, 0. Physics start with 1, 0. So is there space in this bucket to insert the value of physics? Yes or no? No, there is no space to insert. And that's why we need to split it. Can we split it here? So to split the record, we need to check the value of I and I2. Now I is equal to I2. So we cannot split the bucket. We cannot split the bucket. So what we need to do? We cannot split the bucket. Why? A single pointer points to the bucket. I is equal to I2. So we cannot split the bucket. Means we increase the value of I by 1. It is 3. Once we increase the value of I by 1, the first step is that the bucket address is double. It double the size of bucket address. 8 records. Okay, and then here it is inserted here. After this we need to add a bucket. Previously there were 3 buckets, now it becomes 4 buckets. Okay, now accordingly adjust the pointers. So first 4 pointers points to the first bucket. Now which bucket we have split? We split the bucket number 2. So one pointer points here, one pointer points here. We split bucket number 2. Then one pointer points here and the remaining 2 pointers point here. Is it clear why we do this thing? One pointer here and one pointer here, because we split bucket number 2. And that's why one pointer remaining 2 here. So here now in this case, what is the value of I1, I2? Tell me. What is the value of I1? I is equal to 3 now. What is the value of I1? 4 pointers are point here. So I1 is equal to 1. Means only first bit is considered here. If the bit start with 0, hash value start with 0, all the records stored in the bucket number 1. Is it clear? All the records stored in the bucket number 1. Only first bit is considered. Now, what is the value of I2? What is the value of I2? Anyone? What is the value of I2? 3, correct. What is the value of I3? 3. And what is the value of I4? 2 pointers point here. Correct. It is 2 less than 1. I minus 1. Is it clear? Now, accordingly, we need to again reorganize the records. First one, it is music which is 0. Start with 0. Now, we are not going to rough it. Now, the table. First, computer science, Srinivasan. Now, we are going to consider first 3 bits. For computer science, what are the first 3 bits? 1, 1, 1. So, 1, 1, 1, follow the pointer. Where it is to this bucket. So, Srinivasan, computer science, 10101, some salary. Next, with finance. What is the finance? First 3 bit 101. So 101, follow the pointer. Yes, there is a space. Finance 12121. Next, 1515 Mozart with music, which is already there. Which start with music is 001. You can observe 001 means follow the pointer. It is already there in the bucket. Next one, after music, physics, Einstein physics. What are the first 3 bits of physics? These are 100. So 100, follow the pointer. Einstein 2222 physics. Next one, after physics, history. History first 3 bits 110. Follow the pointer 110. Follow this pointer of 110. Yes, there is a space. So history. Okay, what is the name of that person? History, Il Said. Okay, Il Said 32343. Now the next one. What are the first after history, physics? What are the first 3 bits of physics? 100. Follow the pointer. 100. Is there space? S. Physics. What is the name of that person? Gold with physics. So I think it is clear to everyone how the values of I are increased and how the buckets are inserted or created as per the requirement. And if we delete the records, we need to delete the buckets. Also, now see the next one. Okay, so that whatever I have taught you already, that is here in this. So Mozart, Einstein, bucket address table, now it becomes 8, whatever already now we have seen, it is here. Now the next record, how it is inserted. Now the next record is computer science again. Sorry. Next record is computer science again. You can observe here. So it is inserted here. New bucket is added here. This is all these 4 pointers. So it is one pointer points here. It is 3, 3, 3. One more bucket is inserted. Here you can observe that. Here you can observe that there are 3 buckets. Okay. Here there are 3 buckets. As per requirement, a new bucket is inserted here. Here there are 4 buckets. Then accordingly, this is the next. So here you can observe that all the records are inserted according to their hash value. I is equal to 3. That's why first 3 bits are considered and according to the records are inserted. Now in this case what happens? See, in this case what happens? According to this, the computer science start with 111 something. So first 3 bits are 111. There are only 2 records we can store in a bucket, but in the file there are 3 records. Now the file ends there. There are not so many records remaining. So in that case, instead of increasing the value of I, a overflow bucket is used here. Instead of increasing the value of I, overflow bucket is used. Why? Because there are so less number of records are remaining. If there are so many records, then what we need to do? We need to increase the value of I. But as there are very less records are remaining in the file, here instead of increasing the value of I by 1, here only the overflow. Now, what are the benefits of extendable hashing and what are the disadvantages of extendable hashing? The first benefit that we know that hash performance does not degrade as the file grows. Why? Because here we create the buckets as per requirement, and that's why minimal space overhead. No space waste at the start of the file. Initially, no space overhead is there. Initially, we start with only 1 bucket, then 2, then 3, then we increase the value of I, then we can say 7 buckets, 8 buckets as per requirement. So that is the major benefits of extendable hashing. But disadvantage is that here extra level of direction is used. Means here along with this bucket address table is used. That is extra level of direction. That is one disadvantage. Bucket address table may itself become very large. It is possible I is equal to 32 may be there. So in that case, it cannot fit in main memory. We need to store it on the disk. Again, that increase the number of IO operation means disk operation are increased. So the solution is that use the B plus tree structure. Changing the size of bucket address table is somewhat expensive. Means I is equal to 1. Then we increase it by 1, 2, 3, 4, 5, etc. So that is somewhat changing the size of bucket address table is expensive. Alternative solution is linear hashing, allowing the increment equivalent to bucket address table, but here more overflow buckets are used. In linear hashing, more overflow buckets are used. So some advantages are there, some disadvantages are there of this static hashing and dynamic hashing. So here I think everyone is clear with indexing and hashing. Now when we consider or compare the ordered indexing and the hashing, the indexing technique, cost of periodic reorganization is there. As sequential file system is used in the indexing, whenever we insert a record, if there is no space in the file, where we store it is in overflow blocks or overflow buckets. So that increase or periodic reorganization is required as so many overflow blocks are created. So that is one of the disadvantage of ordered indexing. Cost of periodic reorganization is very large, but insertion and deletion is somewhat simple in indexing than the hashing. Now expected type of queries, hashing is generally better at retrieving records having specified value of the key. Means for specific key is there, value is there, then hashing is useful. For example, if we want the record of all the customers whose salary is equal to 80,000, equal to 80, specified value is there given, then in that case hashing is useful. But if the range of the query is common, then indexing is useful. Means what? Find out the records of all instructors whose salary is between 80,000 to 90,000. So in that case, the indexing technique is more useful. Now PostgreSQL support hash indices but discourage use due to poor performance. Oracle supports static hashing organization but not indexing, and SQL Server support only B+3. So in this way, this is about the indexing, ordered indexing and hashing. Now